So good morning and welcome to today's webinar for the perfect order index solution. We're going to be spending the next 45 minutes or so together. There will be a Q&A session later on at the end of the presentation. But before we get to that, let me just quickly talk through the agenda. We're going to do a quick introduction to our speakers today and what our collective experiences are in the supply chain space, specifically when it comes to the consumer products and manufacturing space. We're going to talk about the supply chain challenges in terms of what the problems are, who ultimately in the organization cares about them, and why they should care about them. We're also then going to move into the actual solution and how we approach the specific set of use cases. We're also going to talk about the opportunities and the benefits of our solution. Then we're going to see a demo, a quite extensive demo between Tableau as well as Informatica data quality. And then in the end, we're going to morph into a stream around what are some of the services and work streams to get you started with tackling a perfect order index type of solution. And then in the end, as I already mentioned, we're going to hit some Q&A. So here's some housekeeping items up front. So again, please mute your lines in case they're not already muted. This webinar will be recorded and the link will be shared afterwards. Any questions that you may want to pose during the Q&A part of the presentation, please just enter them in the chat window. And again, the copies of these slides will be made available as well for people who request them. So, all right, without further ado, let me introduce the speakers. So to the right-hand side, you have my esteemed colleagues from Paradigm Technology, Mohit Sahgal and Anshuman Sindar. Between the both of them, they probably have decades of supply chain experience and analytics and IT experience when it comes to digital transformation type of programs. They're from our esteemed partner, Paradigm Technology, which is one of the key partners that we in Informatica rely on to implement our technologies. Myself on the left, again, I'm not going to spend too much time on this, but I'm basically running the go-to-market strategy for the manufacturing and the industrial space overall here in Informatica. Again, you have both of our websites here if you want to get some more information about Informatica or Paradigm. All right, so let's talk about supply chain challenges. So over the last 20 years or more, actually, companies have continued to implement and re-implement and upgrade their ERP solutions over time to get more powerful use cases under their belt. But what has come out ultimately, as we look at those implementations, is that we're still grappling, or the industries are still grappling with the order management process and its integrity. So when you look at this survey here that was actually done by IBM Research a couple of years ago, when you look at the key challenges that executives are still attributing to the order management space, let's focus on the top 4 or 5 here on the left-hand column here. So we're looking at ultimately the on-time fulfillment and adherence to commitment dates for orders, and that's inbound as well as outbound orders, the actual order accuracy, and the processing errors attributed to a degradation in the accuracy, the associated labor overhead when it comes to not only taking on orders, but actually also processing or reprocessing orders, and then also the order throughput. So how can you actually get more orders processed in a specific set time frame? So as you can see here, many people are concerned about this, and again, this has not gone away despite of the increased investment over the years in, again, additional ERP capabilities, investments into CPQ or configure price quote type of tools. Now, what are some of the problem areas? And I've alluded in the previous slide already to some of this. So let's look at these here from left to right here. So labor allocation. So one of the things that obviously is directly impacted by the order integrity is the labor allocated to actually not only process the order, to initially take it on and get it into an electronic format, maybe from some sort of EDI capability, but actually the actual physical picking of the order, the assembly of the order, the actual shipment of the order, the reverse logistics associated. So if you don't know what good state your order is in or where your parts are they the correct parts, there's a lot of labor overhead or excess labor overhead that gets allocated with this. More importantly, you want to also plan around where you need that labor physically to be located in the supply chain to actually optimize that process. When it comes to order and inventory visibility, similar to inventory allocation, you're ultimately trying to figure out where's the best bin number, if you will, to fill a specific order for a customer. So if you don't have the visibility of where the order is, where the inventory is, where alternative part numbers are, if you're not aware of supersessions, you cannot allocate that inventory ultimately in the most productive way. Service fragmentation, similar to what you see on the top end right here, channel fragmentation is typically order management processes are not an enterprise-wide process. It's typically done on a plant by plant, business unit by business unit, or even product line by product line basis. So it really depends on what business unit is executing the order, what kind of channel partner is executing the order, what kind of intermediaries the order flows through, and that varies widely. And this wide variation ultimately drives integrity problems in the order management process. And again, that's also true for the reverse logistics piece as well. And then lastly, when you look at order configuration and tool integration, partner dependency, it's somewhat down the same line, but just a different twist of things. So again, CPQ tools have been working on automating order configuration processes to take the error rate out of it, to make it more seamless and also faster to actually configure orders. But again, it typically takes multiple different tools to be integrated. A CRM tool to get the customer information in, an enterprise parts catalog, typically multiple thereof, when you have complex products, for example, to be integrated to actually complete that process. And then again, typically somewhat related to the channel fragmentation, the dependency on partners sometimes to actually execute that order, not just fulfill it or even ship it, that also creates ultimately areas that are problematic. And when I say areas of problematic, I mean ultimately these, and this is just a snippet, if you will, of some of the major data elements that could be corrupted, meaning they're either differing between various different tools, they're differing by business unit, by plant, or even by product line. So let me just pick a couple of those, not all of those. Minimum order quantity, MOQ, a unit of measure, which is typically your physical dimensions of your product. If these vary, you ultimately have an integrity issue because you're shipping potentially the wrong part, you're shipping it in the wrong quantity. Is one in a box, or is one a box of 12? So this is the classic example for minimum order quantity. Units of measure, is it English versus metric, right? That's important because you will probably encounter container blowups because your product size and your packaging will be too big for, let's say, a 20-foot container, and then you suddenly end up with, let's say a small fraction of the next container having to be allocated to actually get that shipment out the door. If you don't do that, then you have a customer satisfaction issue, you're late to your shipment dates, so, and so on and so forth, because it will ultimately extend credit. We also have differing lead times between various systems. We've seen situations where multiple different planning systems continuously override each other. Ultimately, when the lead times are incorrect, that you will ultimately end up with, let's say, a three-week lead time being the norm, you'll end up with maybe a 6-week lead time if you look at other systems. Discontinue, make, and buy kind of flags, right? So this is the classic example where you continue to make products that actually, or even procure the raw materials for it, but they've been discontinued into being sold into a specific market. So you ultimately end up with orders that will never get fulfilled. This, ultimately creates incorrect projections and forecasts, and ultimately also customer satisfaction issues. On the flip side, if you stop making items but you continue to sell them, you also obviously maybe have forgotten to also buy raw materials for it. You continue to sell them, but nothing gets made in the middle, ultimately in the process. And then one more last thing, country of origin. So that's an interesting one because we've actually had customers in the past that indicated to us that they would actually get bulk shipments, whole container loads worth of items from their factories in Asia, for example. Then we'll break them apart in the local warehouse and individually package them, where we've seen situations that the actual sticker on the part actually says made in, an Asian country, but the box outside is proudly proclaiming made in the US. Well, that's a problem because not only is it somewhat deceiving the customer, this could actually carry a fine by Customs and Border Patrol. So again, I'm not going to go through all of these, but these are some of the data elements, if you will, the attributes that are ultimately the technical reason why these business problems on top ultimately end up being of such magnitude. So what have customers done around this? In the past, people created these massive dashboards, balanced scorecards. They ended up with 28 to multiple hundreds worth of KPIs to measure how good the order management process works. And in MESA and APEX are classic industry associations that have actually been published these best practice KPIs. The other thing that is to note that we've actually had third-party research, and that's actually listed below. We've actually seen how poor the data quality around what we call thing data, like product and raw materials, is today across multiple industries, but specifically in manufacturing. So we're looking at 10 to 34% of item data or product data actually being accurate, complete, and unambiguous across the enterprise, across multiple different data silos. But even the best in class is kind of shocking, because if you think 10 to 34% is poor, the best in class can only really achieve 69% of that data being in an accurate state. So this means ultimately you're running your business with a third of the data ultimately being poor. And that's actually the market leaders, if you will. So that's kind of a scary metric. Now, what we're proposing here is two things. One is we want to propose to you a switch from the OTIF, the on-time in full metric or family of metrics, and the looking at the poor data quality that you currently have in the organization, into a new role paradigm to look at something called perfect order index, or POI. And to that metric to drive your order management process, some solid data governance practices, and to really focus on how do you harness good data quality practices within your organization. Because what you're trying to get to ultimately is a good on-time score, a good complete order score, some damage-free orders obviously being the norm within the organization, and accurate documentation, meaning the PO, bill of lading, and even the invoices. Let me just also mention one thing. If you look at Amazon today, every retailer on Amazon has actually something called the POP, the perfect order. They call it percentage rather than POI, but it's the same paradigm. If you think it's hard to get on-time, complete, damage-free, and accurately invoiced orders, Amazon actually would grade you also on how many bad comments, poor reviews, or even customer service requests you get associated with an order. So if you can layer that on top of it, what Amazon is trying to get to which is a 95% score, that makes it even more impossible to actually get to that. But again, this is the, if you will, the best in class way to look at things. So what does better data management ultimately do? We're obviously trying to get you to manage complex orders more successfully, multiple different parts, bill of materials from multiple locations being assembled, eliminate complete entry errors, decrease the rate of return, lift customer satisfaction ultimately, to be in line with my Amazon comment earlier, and also ultimately to optimize the inventory levels and the associated working capital associated with the production and inventory of this merchandise. So how do you make money with this, right? So now we're talking about where you want to go to and what the issues are, but even if you would resolve the issues, what can you be looking forward to in the end? So again, this is not us talking about this. This is what customers and third-party industry analysts have said. So with adhering to good POI practices, you can lower your order costs from the processing perspective by more than half. You can get your accuracy for an order up to nearly 100%. And you can ultimately reduce the labor overhead associated with just the entry process by close to 2/3. So what does this mean in actual dollars? If you're looking at an average manufacturer with about $15 billion in annual revenue, and I know some of you are on the smaller side, so again, make the adjustments proportionally based on the next figures here, you can get somewhere upwards of about $7 million in annual benefits by just reducing your order management errors, right? And that's just purely from instituting better data management practices. So over 5 years then, for every dollar invested, and this is what the median ROI comes down to. So for every dollar invested over 5 years, you get $14 back for that investment in improved data management practices. So if this is nothing of interest to you, then obviously we have some more education to do, but because this is a huge return and a huge opportunity for you, just fixing your data quality and your order management process as a consequence. So what are the typical systems that we see and that we have to ultimately integrate with and create this common data quality set when it comes to product, but even also customer data or vendor data, for example. So this is a classic landscape. I know it looks a bit confusing and a bit busy here, but the reality is this is actually a simplified view of what the typical environment looks like. So on the bottom here, we have the source system. So we have partner portals and catalogs, some electronic data interchange type of applications. You have a web portal catalog if you're already opening your customers, even your B2B customers, via some sort of e-commerce type of portal. We have typically multiple warehouse management systems, typically on a plant-by-plant basis or at least regional. Typically one or more ERP systems. Multiple manufacturing execution systems or replenishment systems. You have typically, again, from different vendors many times, supply chain, factory planning, and demand planning tools. You will have hopefully only one product lifecycle management tool from the initial design of your product, especially when they're more complex. You will live off Excel. Again, this is pretty much standard, I guess. And many, access databases to manage catalog information, specifically when it comes to special orders. And then obviously some sort of supplier relationship management database to keep your vendor information in check. These systems, or some combination of one or more of those, two or more of those, will ultimately funnel into this mid-level here, which is the customer order process application, and the procurement, so the raw material procurement application, the infamous inbound order management flow. And these, again, will execute orders, reverse orders, and ultimately the top level here is the analytics piece of the pie, or the planning and forecast piece. So on the left-hand side, you will have some sort of mobile tracking that you may already offer to your sales force, but also maybe to your customers. You will have some sort of engineering data lake that your quality engineers can leverage to really improve products over time based on customer comments, service issues, returns, warranties, and so forth. You will have some sort of enterprise data warehouse, most likely, hopefully in the cloud by now, but if not, it's on-premise, most likely to do some sort of S&OP analytics, to do some financial planning. You will have your SCADA systems or SCADA dashboards, ultimately to get some real-time yield information from your execution processes in your plants. And then ultimately on the supply chain side, you will have at least one forecast a day, maybe even one a week. Some of you already have twice a day kind of forecast plans that they will execute for your inbound and outbound supply chain scheduling. So again, what we're proposing is not to reshuffle any of this, because this will be super costly, and this is not what we're after here. We're trying to ultimately institute a central way for all these systems to talk about a specific product record. And obviously you have thousands or tens or hundreds of thousands of products that you ultimately are procuring and selling. This central instance, again, call it a product data quality lake or a product data quality instance or a hub. It doesn't really matter what you call it, but this will create this integrity across all these products when they're created, all the way down to when they get retired. So next we're going to touch about our solution approach, and I'm going to hand it over to my dear colleague Mo.
Thanks, Stefan. As Stefan just indicated, data required to effectively measure supply chain performance often must come from many heterogeneous systems across the business. A recent McKinsey report entitled "Uncovering Cash and Insights from Working Capital" made some important notes, specifically to improve customer experience, reduce operating costs, and reduce working capital requirements isn't sexy and often is painstakingly technical. This is very important. As the McKinsey report highlights and reminds us, it's all about the data, exactly what Stefan just highlighted. That is, systemically collecting the right data in the right format in a consistently repeatable manner is critical to enabling decision makers to analyze complex events from across the landscape. Ideally, organizations should build their data collection into their core IT processes. Those who can draw on a single integrated system to automate the process will have an easier time of it. Informatica has responded to this challenge, and what you see in this diagram is exactly that, an integrated stack to make measuring supply chain performance easier. Let's just review the diagram in a little more detail. What the diagram shows is basically 4 key products: a centralized system of managing data quality rules, IDQ, an enterprise data catalog to manage critical data elements and KPIs, EDC or EIC, a way of storing the data, or data lake, or other data integration hub, and 4, a way of mastering customers and products, MDM, master data management. So now let's take a look at what does this infrastructure provide us. Well, if we look at the traditional supply chain performance approach, it illustrates a maturity curve in of itself. So let's dive into detail of what these components are. Reading left to right, most organizations are still very focused on cycle time. Some companies have evolved to include whether or not a shipment was complete. Today, these 2 metrics represent what we now know as OTIF, on time in full. But as you can see, it's really an incomplete picture. What about returns and adjustments for errors and damages to products and so on? And more importantly, what about reconciliation of orders to actual invoices? These cross-functional metrics, or indexing as it's often known, rather than looking at each metric individually, helps you understand the overall impact of missing any of the other key elements associated with knowing whether or not the supply chain is performing as it should. Even though each individual metrics looks exceptional, when you combine all of them together, the picture is quite different. This has a direct impact on working capital, accounts receivable, and logistics and costs. Let's take a look specifically at the financial impact. Customers demand continuous improvement, and markets reward them as a result. For example, a recent study by AMR Research found a direct correlation between perfect order performance and some key financial and market indicators. About 25 companies were included in this best practices supply chain study, and those that used perfect order as a performance measure greatly outperformed the S&P 500, producing an average total return of about 18% compared to their peer group in the S&P. Companies with a perfect order rate of about 80% or higher are 3 times more profitable than companies with perfect order rates in and around the 60% or less. This study then found that better perfect order performance also correlates strongly to higher corporate earnings, specifically earnings per share and return on assets. These financial results are significant, and as Stefan indicated, something to take note. So let's take a look at and see how we can actually build a perfect order solution. So with that, I'm going to turn it over to my colleague Anshuman to explain the demo.
Good morning, everyone. This is Anshuman. I just wanted to show you what I'm going to go through. So we'll go through, this is a brief diagram that summarizes the movement of data from internal ERP systems in various systems that a company might have through the data quality engine, the Informatica IDQ, and data movement. So we'll go through some of the issues that present themselves and manifest themselves in the various systems and how they can be cleansed. We'll go through some dashboards which are specific to the areas which Mo and Stefan identified around perfect order index and metrics. And then we'll show the cleanse data which manifests itself after the cleansing is done through the IDQ engine, and you'll be able to see how it represents in the various dashboards that are used for presenting data to be able to make decisions. So this is a data set that is set for about 27,800 rows. It's raw data summarized by product line items, containing product category name, product category numbers, products that fall within the various categories that are summarized. This is the highest level of the product category. It might contain 2, 3, 4, sometimes even more levels of aggregation. As you can see, this is a fairly medium-sized data set, but it has all the different products that we'll review. The data also contains order line item level dollars aggregated by these categories, and we'll show you in the dashboard how that is represented. The dollar line item level data can be reported weekly, monthly, quarterly, annually in operating reports and used for analytics and decision-making purposes. The product level information can then flow into enterprise systems. So the information that is aggregated at the dollar line item level, which is for these products, and supporting information about these products can flow into enterprise systems, which include ERP systems and many other systems that will be crucial for companies' operational performance. The information could include SKUs, packet sizing, retail and wholesale pricing as it relates to distributors, resellers, online and other channels. That is then stored in other systems, such as product lifecycle management systems, supply chain planning systems, factory planning systems, demand planning systems, CRM, CPQ, warehouse management, inventory management, shipping and label, and freight systems, and the list goes on and on. There might be many internal systems that the data would flow for these products, and the detailed level of products that are below this high level aggregation. That data flows through all these systems that I just mentioned. The product manufacturing information is also a pretty large set that relates to these products that goes through many systems and is used in many systems. So data like make locations, country of origin, percentage of parts that are bought versus manufactured in-house. These are some examples of data that is created, acquired, and cascades through many systems that I mentioned above. Now, the reason I've mentioned this is any poor data quality at the product level for these products would also cascade through these systems. So if the SKU is incorrect, packet size is incorrect, country of origin, labeling, make location, SKUs, which are make or buy spread between the SKUs, and PLMs, the data across PLM systems, all that data would cascade through. And if there's anything incorrect in those systems, it'll cascade through all the systems. Which then, and we come to the point of this entire presentation and webinar, if there are those data quality errors or the detail at which the data is acquired and saved is not accurate, it has actual tangible implications. It could result in orders being shipped incorrectly, so returns, repackaging of orders, relabeling, reissuing of bill of lading and invoices. And all these can delay payments or extend payment terms as it relates to customers not being happy and have to return the orders. They can also result in lost orders, and at the very least, cost a lot of money when they require rework by the operations and warehouse staff, by the factory planning, by all the various processes and people that are involved in reshipping, relabeling, repackaging, reissuing bill of lading or invoices, and so on. So the most important piece out of this presentation, and I'm focusing on this list of products, is that the issues, if an order is shipped, the product information or because of any various reasons that I've mentioned, if the order is not accurately shipped out, it is even more important because we'll have to keep excess inventory. It is even more important to actually focus on these issues, because if there are errors and they result in incorrect shipping to the customer and repackaging, as I mentioned earlier, we have to keep excess inventory, and that results in truly not completely fulfilled orders. The excess inventory is really to use as a working capital to repackage, remake, reissue, and reship the orders. The working capital that is locked in this excess inventory then is not a very productive, to say the least, use of that capital. And saving that working capital from excess inventory can actually result in saving interest expense at the very least. And of course, in addition to all the efficiency loss can be prevented. So we're going to demonstrate the metrics that can be used to calculate the true efficiency of order fulfillment and supply chain. We're also going to show that data quality improvement, and I'm going to show you what those data quality improvements that can result in increased transparency of the supply chain and hence result in better fulfillment of orders. This is a dashboard that is created using the data set that I showed earlier. The order line information is this first column is what I was showing earlier as product information. As you can see, this is the exact same product category data set that we had earlier, except that this is the actual dollar amount aggregated by the products. So this first column is the dollar order line information aggregated. The second column is OTIF, which is on-time in full shipment of orders, which measures efficiency of outbound shipment of orders, but not complete order fulfillment. And I'll just explain that in a minute, what complete order fulfillment means. But before I do that, let me just point out one more thing. There are, in this data set, a few data quality errors. One is, if you look at this water dispenser, there's a product ID that is mentioned 3 times. So there's a water dispenser 1250B, water dispenser 12501, and water dispenser 12511. These are all data quality errors in the data set, which prevents the accurate, even if you have the right metrics, it prevents the accurate portrayal of what those metrics are showing. So as I mentioned earlier, the POI doesn't measure the full efficiency of order fulfillment. It's not a complete order fulfillment efficiency. The perfect order index here is meant to demonstrate that. It illustrates how we measure the complete order outbound shipment of the order and any returns that might happen. So the difference between POI and OTIF, for example, if you take high pressure cleaners here, it's nearly a 10 percentage point difference between OTIF and POI. This difference between the two shows that what was sent out doesn't accurately reflect the efficiency because there are returns. And more importantly, there is working capital that is locked because of this difference that has to be and locked to make the reshipping, relabeling, processing the orders, and sending the orders more accurate. If you see here on the last column, this is the total working capital, and the chart here represents the difference between the POI and the working capital that is consumed because of this. Let me just summarize this a little. So this chart actually displays what part of this working capital. So, for example, in the example we were looking at, the high pressure cleaners, 8.56%. 8.56% in this case of $26 million in working capital is a significant amount. And this chart here is actually about 4.1 million, which is the amount consumed from the working capital due to the inefficient outbound orders and the returns that have to be processed. And if POI is actually measured correctly, then it's at least we know how much can be saved. Now, on the bottom, these are returns. So the bottom right is there are two. The bottom right here is incorrect document processing, and the bottom left is damaged returns. I'll take an example of incorrect document processing first. So in the bottom, you can see that there are 3 areas where the orders were processed because of various reasons, right? So minimum order quantity was incorrect. So for example, if it's a dozen versus just 1, so the order was for 1 dozen, 12 pieces should have been shipped, but only 1 was shipped. This is a hypothetical example. The second is a unit of measure. This is an example where something was in centimeters, but was shipped or manufactured in inches. Now, in this example, it is a significant reprocessing because a larger number of people and processes are affected if the order has to be remanufactured or taken out from the, or if there were a whole batch was incorrectly manufactured, it has to be remanufactured and taken out. The old batch is pretty much a loss. It has to be remanufactured, repackaged, reshipped, relabeled. All those, the entire supply chain is affected. The third one is unknown reason. So this is, we don't even know if there's an error in these orders. They were returned, but we don't know why these returns happened. And that is also significant data quality error, because if you don't know what has to be fixed, you can't fix it. On the right here are damaged returns. So there are some cases where the water, for various reasons, these different within these different product categories, the orders were reshipped or had to be reshipped because they were returned. I would also like to point out a couple of other things. There are nulls here as well as blanks, which are simple data quality errors. Let me switch to Informatica product. This is an IDQ, Informatica data quality screen, where there are some fixes that have been made. And what we did was put the entire data set through IDQ, what you see here is what percentage of it's a profile. It's what percentage of the product category and product numbers were incorrectly captured. And if you remember from what I had shown earlier, there was a product which had 3 different product numbers, item numbers, 1250B, 12501-1, and 12501. 12501 is obviously the right one. The others one are data quality errors. This shows a histogram, which is charting out all the different errors. And there are a few more here on different products. And it's basically showing the top 5 and how this spreads across those. This screen is from Informatica data quality after corrections are made. So there are after data profiling is done, there are rules that are set in IDQ, and the data can be pushed through. Obviously, this is a very simplistic example of data corrections, but at the bottom you can see that 12501, which was an incorrect part number, has been fixed, and as the data goes through IDQ, and on top here is a separate screen on what those data quality rules were to make the fixes. Let me switch back to our dashboard, and what you see here is a corrected dashboard. So if you see the 12501 is only listed here once, but what it has resulted in is accurate order line, accurate OTIF, and accurate POI. Now, the difference in this case is not very large, it's 4.76%, but that too results in a fairly, it's not a very big, but it's a $19,000 working capital impact. In aggregate, all these pieces, which are differences between OTIF and POI, effectively a percent, if you add up everything as a percentage of working capital, it's a significant amount. The other piece I wanted to show was that the nulls and blanks are removed from here. Now, you can see that the minimum order quantity errors and incorrect unit of measure, those are here. And those are larger errors, which are not just fixed by putting the data through a data quality tool. You can, and that's more of a data integration and cleansing exercise that has to be done at the source system level so that it can cascade down. So for example, if the reason is unknown for why this particular vehicle wash system products were returned, then it has to be added. There might be a screen that somebody is entering as the returns come in. A process has to be improved, or systems have to be modified to make that change. It can also be added downstream where things can be updated as even if it's errors are created in the source system, downstream from the source system, processes can be added, and technically it can be modified so that the dashboard represents exactly why the error was, and somebody can act on it.
All right, so great, Anshuman. Thanks for the demo. So I just want to recap what everybody just saw here. So we obviously showed you how a switch to the perfect order index paradigm renders us some new analytical insight in order to understand what your true order performance is and how relevant this is to your financial health when it comes to your use of working capital. And we obviously used a product data quality scenario here to demonstrate this. We also showed you how to profile your item data, your product data, and to highlight what some of the problems are and how big they are across various attributes. We also showed you how to create a business rule. We actually showed you an example of one being created, although a fairly simple one, and how to remedy some of these data challenges. And then ultimately, how the performance improved after you did the fix to the data quality in your product data, and what again the impact of that is to your perfect order index score, and again to your working capital associated with that lift in perfect order performance. So with having said that, I'm going to hand it over to Mo again to talk to you about how to get started and what next steps to take.
Thanks, Stefan. So there are a number of options that we have in order to get started, and the array of options are summarized on the slide. First, we can start with a business case and a value proposition around how all the four metrics that we talked about between OTIF and POI, how those impact the organization, what the working capital impact is, and how the reduction in working capital can affect an organization's financials. Second option, which can be combined with the first option, so all of these options can work simultaneously or independently, is to conduct a rapid technical assessment of the existing environment, trying to understand, of course, what are the nature of the data quality issues or data quality anomalies that occur in the source system, and what impact that has on actual supply chain performance measurement. You can also take a look at that data quality layer, as Stefan was describing, how that should be constructed and how that should be instantiated. So whether that's a data integration hub, part of an existing data lake or a data warehouse environment, what are the additional opportunities for the enterprise information catalog, and data governance. All those components can be looked at in detail, as well as developing a transformational roadmap to achieve the target state. Third option is to take all the two options previously discussed to the next step, which is actually demonstrating how this would work, and creating a similar dashboard to what Anshuman just described, to visualize where the key challenges are in the supply chain, and to quantify the nature of the impact that needs to be addressed. And then the first is, or the last one is, how can we actually help the organization transform through an end-to-end solution? And that might be building out a new infrastructure, assisting with the implementation of any one of the Informatica components, and then assuring that the entire solution scales to meet your requirements. So in general, these are the four different approaches. And again, there's an array of options here, many of which or all of which can work together simultaneously. So with that, I'll stop and talk about some next steps. So hopefully you found this discussion interesting. We have set up an email where you can communicate with us and we can communicate with you. We've also included our individual emails where you can ask us specific questions, and you can also go to the Paradigm website where you'll be able to download these materials as well as the recording and review them yourself. So with that, I'm going to stop and see if the audience has some questions.
So I've seen some questions that were collected here already. I see one question that says, how we go about uncovering specific value that could be derived for our organization by doing this POI paradigm. So again, so one of the options that Anshuman just mentioned earlier, I'm going to take a stab at this, is to create what we in Informatica call the business value assessment. So this is ultimately a way to do some discovery, to basically understand how processes and what kind of processes are affected to what degree by this poor data quality. Obviously, this is around order management processes primarily, but again, we can also broaden this. And just because we have done this before, there's no single order management process typically in the organization. So we really try to collect all of them, and then put a financial value against that in terms of additional cost, productivity loss, lost revenue or new revenue opportunities, logistics cost impact, and so forth. So that's typically how we go about this. And then it would morph into some sort of technical discovery, a proof of value. So when you look at up at Mo's initial slide earlier, from left to right, that's how this typically will progress. Another question that just came in is, how can we get this started with our executive team? Well, again, this is somewhat aligned with the first question. typically you want to build or sell this concept internally, because this is actually a paradigm shift for many organizations that live by OTIF or live and die by OTIF today, or some sort of cycle time index. So executives typically want to understand, how much cost base has this change, what software is required, what implementation impact is, how can we roll this out, piecemeal, step by step, not to shell shock the organization into a new type of order management process. But again, at some point they will ask, what are we gaining from all this after everything is said and done? So this is again where the BVA will come to play. I think this one, I think you guys on the paradigm side can take, what are the minimum technology requirements? So Anshuman, Mo, do you want to take this?
Yes, absolutely. I'll take it. So when we think about this, the critical aspect is somewhere to land the data, right? So is there an existing centralized data integration hub, data lake, or existing EDW infrastructure where order information from across the supply chain can be landed? Then the next critical aspect of this is applying consistent data quality to the various attributes and columns within the data, and then the ability to calculate OTIF and POI. So those are the basic technical requirements. So there's not a lot. The evolution then is, how do you apply consistent data definitions to all of the attributes that comprise of a product, customer, order, and so EIC is a critical aspect that represents the next level of maturity in the data infrastructure. And then the third, or the last component rather, is master data management. So typically a lot of organizations, even today, don't necessarily have a good way of mastering products across the supply chain or mastering customers. And so MDM does just that. And that brings the data infrastructure again to another level of maturity, because now we have a way of constructing 360 views of how customers are interacting with the organization, what orders they have, their book, bill, backlog status, and we're also able to generate POI at both the product level as well as at the customer level. So those would be the maturity scales and the minimum technology requirements.
All right, let's take a couple more questions here. So there's one here. Is the dashboard free or for sale?
That's a good question. So the dashboard would come as part of a paid engagement. It's something that can quickly demonstrate value. We've created a standard record layout. What that means in English is that we know what columns are required or what data is required from the source systems. So we can work with an organization on populating those columns from various source systems. And once that's done, the dashboard will generate the various metrics between OTIF, POI, and working capital. So again, this can be done in a fairly rapid manner, but the dashboard is really part of the paid engagement.
Okay, let's take one last one here because we're running out of time here. Is a data lake or a data warehouse required for this?
Yeah, so there are no doubt a lot of notions around a data lake or a data warehouse, but more importantly, we can accommodate this in any infrastructure that a client has. So if there's an existing container, whether it's a data mart, data warehouse, or data lake, we can leverage that infrastructure. If no infrastructure exists, then we can stand one up to accommodate that, whether that's done on the cloud or whether that's done on-prem. So it really depends on what the client has and what we can leverage. So our objective would be to maximize the utility of an environment that already exists and be able to quickly demonstrate the calculated values and the impact on working capital. And so that would be our focus. But the important point is we can integrate this solution very quickly with an infrastructure that already exists, or we can create one such that it can be used in a consistent and repeatable manner as the technology and business requirements dictate.
All right, cool. So thank you both for answering some of these questions. So at this point, we're at the top of the hour here. So I want to, again, thank everybody for dialing in and watching this webinar today. I really appreciate you taking the time out of your day to join us today. Again, if you have any questions for any of us, you see our information on our screen. You can also go to the Paradigm Technology website for the POI solution to get further detail. There's a cool video, a white paper that might be useful to you to sell this concept inside your organization. And with that, I would like to thank you again and hope to see you next time. Thank you.